Let's try one last problem just like this. In this last problem, Mensa membership requires an IQ above 131.5. IQ scores are normally distributed with a mean of, 100 and a standard deviation of 15. In part A, we're looking for if one person is randomly selected from the population, find the probability of that one person having a score of at least 133. So, same idea as the last problem. We're just dealing with one person of at least an IQ score of at least 133. So we'll start out with our normal picture, normal curve. We'll talk about the fact that we want our IQ scores of 133, and we want them to be at least 133, so it's greater than 133, so this right area. And we're just talking about one score, so I'm just going to do this normally. I'll start out with my normal CDF, and we'll start out with our starting value, which is 133, comma, this graph continues on to the right forever towards infinity, so we'll use a positive 10 to the 99th, comma, next part is we have to give the mean, which is 100, comma, the next part we have to give is the standard deviation, which is 15 for this problem, and then our calculator will do all the heavy lifting for us and find the area probability here. Gives us, when we use our calculator, is our 0.0139, and that's our probability. And we're done with at least part A. Moving on to part B, notice we're going to look at the same thing, except for there is a small difference. We're going to still look at the 133 being at least 133, but now we have a mean that we're looking for that is at least 133, and it's a mean of 9 people. So this is where we're looking at our special case because we see the word mean when we're asked for a probability. So we're going to draw our normal curve just like before. We still have our 133. We still said at least 133, so it's still going to be the same exact picture, so to the right. The only difference is, because I'm talking about means here, I need to calculate my standard deviation of the means by taking the standard deviation and dividing by the square root of n. But we already said the regular standard deviation is 15, divided by the square root of, we said our n, our sample size for these means is going to be 9. So we've got 15 divided by the square root of 9. You can go ahead and do the math. That won't be a decimal. Or you can just go ahead and have the calculator do it for you. Why not? So we'll do our normal CDF just like before, starting out with our 133, comma, it's going to keep on going forever just like the one before it, to the right towards infinity. So that'll be a 10 to the 99th we'll use. Comma, just like before, we always input our mean next, which isn't going to change. It's still 100. The only thing that changes with these is our calculation for our standard deviation, which we said is 15 divided by the square root of 9. And we'll close that off and we'll see what the calculator gives us. Notice that your calculator will give you a 2.06, a bunch of numbers, an E, and then a negative 11. Which, remember, that means it's going to jump your 2, and then it will have 10 more places to move. So that's 10 zeros. So we're going to go ahead and say that's not 0, but it's pretty close to 0. So we can't say it's not going to happen, but the chances are slim to none.